The presentation will be on urban scaling of patents and the relation of patent activity with socioeconomic strength. And the study focuses on major German cities and their urban agglomerations. So this is an impression of the city where I'm living and working in Leiden in the Netherlands. It's a beautiful old city. And you see the observatory in top. It's the oldest university in the Netherlands, member of the European League of Research Universities. It's always within the top 100 of the international rankings. And we have 15 Nobel Prizes in physics, medicine, and economics. It's an historic city of Roman origin, with strong cultural and scientific tradition. There we go with the presentation after this advertisement for my city. Our work attempts a novel integration of two established but distinct fields of science. First, quantitative science and technology studies, and particularly patent analysis, and quantitative urban studies, and in particular urban scaling. A further novelty is the use of dual modalities of patent counting or patent assignment, namely analyzing both the applicant address and the inventor address data. And that's important because it accounts for the spatial divergence between administrative headquarters, that's mostly where the applicant address is, and the actual inventive activity, that's where the inventors are. So you get different patent counts when working with applicant addresses or with inventor addresses. Our study focuses on the characteristics of the inventive capacity of cities and their agglomerations, the contents, urban scaling methodology, properties of patent data, scaling of patent numbers, patent activity and socioeconomic strength, influence of economic sectors, patent activity and scientific performance. And the first step is I present some basic elements of our patent analysis. We use the PatStat autumn 2023 version, and the data period is 2070-2023. Eugene Garfield also studied many years ago already a patent, particularly patent citation indexing. So he was already 60 years ago involved in patent analysis. And as I said, I'm really honored to speak in this memory center. This is an example of a patent. The co-author of my work is Jos Winning. He is the patent analysis at our institute. And what you see on this page is the applicants, and called their proprietors. There are three, and inventors. There is a difference between the applicant and the inventor. We see that our patent has more than one applicant and more than one inventor. And this is often the case, but the majority, 92% of the patents in our data set has only one applicant. But nearly half of the patents has three or more inventors. So the distribution function differs substantially for applicants and inventors, as shown in the next figure. Oh. So you see, just a moment. That's quite a quite a different distribution function. For the applicants, it's a power law function, and for the inventors, it's typically an exponential function. Is there a difference between the number of patents based on applicant addresses, PA, or based on inventor addresses? It must be, because as you see, there could be one applicant and many inventors. Yeah. The differences are quite remarkable. We take two cities in Germany as an example. The PA is the number of patents based on applicants, and the PI is the number of patents based on inventors, and then the ratio. You see in absolute numbers, there is already a big difference between Bochum and Munich, but also the ratio is quite different. And let us look at this more in detail. How does these numbers relate for the 24 major cities in Germany with a population above 500,000? And you see that's more, it's a little bit more than linear. And the typical thing is with increasing PI, PA seems to increase disproportionately. So the more inventors you have in a city, the more applicants, the disproportionately more applicants you have in a city. So this is probably a proof of the center of gravity effect. And in Germany, that is typical for Munich. Next, I'll show you some basic elements of urban scaling methodology. Urban scaling is the phenomenon where a superlinear increase of the socioeconomic performance of cities, particularly the gross urban product, GUP, in relation to population size is found. That is the definition of urban scaling, more or less. For a set of cities of different population size, this relation is described by the power law as shown in the slide. And here you see it in graphically. So let us focus on this city in the middle. So there is a power law relation for the entire set of cities, namely this equation. And now we focus on a specific city, city I, with this gross urban product. And this is the urban product on the line below the city. So that is what we call the expected value. We see that for a specific city with population Ni, the real value is given as shown in the slide, and the expected value is as given in the slide. The residual of the scaling relation is given by the logarithm of the ratio between the real and the expected value. This is this expression. And I can show this. So this is the residual of the gross urban product. So it's in fact the difference between the real value and the expected value. If the residual of a city, as given in this figure, is larger than 0, then the city has an above average socioeconomic strength. When it's below 0, it has a below average socioeconomic strength. So the scaling residual is an interesting indicator for the socioeconomic strength of a city. For instance, we found that the residual has a high correlation with unemployment in a city. So all the blue cities you see in the figure above the blue line are cities with a larger socioeconomic strength than the cities below the blue line. And the same is for the FUA. The FUA is the functional urban area, which is the agglomeration of the city. We find the same. So in this measurement, we can, in a quite easy way, find whether a city is richer, is stronger in economic strength than other cities. Then the relation between the number of patents based on inventor addresses and the population of a city. We see that is about linear, a little bit lower. So this is the residual of the patent number. Yes. For instance, Munich. Munich has a far above average number of patents as compared to the set of the cities we are studying. Again, the same as for the gross urban product. When the residual of PI is larger than 0, the city has an above average patent activity, as measured in this case on the basis of inventor addresses. And the same for the number of patents PA based on applicant addresses. So if the residual of PA is larger than 0, the city has an above average patent activity as measured on the basis of applicant addresses. Again, Munich, a large patent activity as compared to the other cities, but there are more cities with a higher patent activity. And we will see that these are specifically cities with huge car factories. We find that patent activity increases with city size, and this increase is stronger for patent activity measured on the basis of applicant addresses, but it is not certain that this increase is superlinear. And what we find is, in fact, in contrast with the earlier literature. In all cases, the measurements show a quite low explained variance. The population size of cities explains approximately 40 to 60%, so about half of the observed variation in patent numbers. Obviously, that's our conclusion, other characteristics of cities also play a role in patent activity. For instance, socioeconomic strength and or the presence of large internationally renowned universities. And this latter asset is not a privilege of the largest cities only. Cities with a high patent activity, that is what we find, are also the cities. Yeah, well, it's the question, are cities with a high patent activity also the cities that are socioeconomically stronger? Now, we can investigate that by calculating the residual of the number of patents and the residual of the gross urban product of the cities, and then calculate the correlation between the two residuals. And for this latter, we construct what we call a 4-quadrant scheme and apply a chi-squared test to answer the above question. So what we see here now is quite interesting, and a comparison of the residual of the patent numbers and the residual of the gross urban product of cities. When both are smaller than 0, then both the the number of patents and the gross urban product is below the average of the set of cities, and here the other way around. And we see it correlates quite good. Cities with a lower patent activity are also cities with a smaller socioeconomic strength, and the other way around. And the same is for their agglomerations, the FUAs, the functional urban areas, and also for the patent numbers based on applicant address. And especially this correlation is quite strong for the city agglomerations. Given the relatively low number of cities in these studies and their agglomerations, we must be cautious with our conclusions. What we can say is that we find a reasonably strong indication that cities, and particularly their agglomerations, with a relatively high patent activity, are predominantly the socioeconomically stronger cities and agglomerations. But our measurements do not provide an answer to causality. But we note that the gross urban product has a longer time scale and is more stable as compared to patent activity. These observations suggest that scaling of the number of patents with the gross urban product of cities instead with the number of inhabitants will show a better explained variance. And this is indeed the case. See the next copy. Here we have on the upper side the number of patents based on inventor address, and then the comparison between scaling with the N, which is the number of inhabitants, and GUP, which is the gross urban product. The explained variance is in the case of the gross urban product better than the number of inhabitants. The better explained variance with the gross urban product suggests again that the socioeconomic strength of a city matters. The gross urban product is derived from economic activities that relate in fact only to the working part of the population, whereas the population size includes all inhabitants of a city. So a next step is a refinement of the total population size to the working population size, and a further refinement to the working population size in different economic sectors. So we did the next experiments, refinement of population size to working population size in total, population size in manufacturing, in trade, in public and private services. We find, and that's interesting, that refining of the population of a city to the working population size, total and in different economic sectors, reduces the variance in pattern scaling only a little bit. Further refinement does not work because a possible problem with refining the working force to only those workers that are supposed to be in the so-called inventive or creative class is that it may end in a circularity, namely measuring patent activity of only that part of the urban population that produces patents. So that will not work. So again, we find a quite strong relation between the socioeconomic strength of a city and its patent activity, both based on applicants and inventors. Then the final research question. Is there a significant relation between a city's patent activity and its scientific activity? Patents are an important part of our knowledge system and in many cases closely related in connection with scientific research. A specific characteristic of a city is its scientific activity. Therefore, we investigate for the 24 cities the relation between the number of patents and the number of publications in international journals. All cities in this study have a university, but these universities may differ considerably in size and international impact. Furthermore, we take into account not only university publications, but also publications of the major research institutes such as Max Planck, Helmholtz Association and Fraunhofer Association, as far, of course, as these are located in the city concerned. In many cases, it is so that a city with a major university, an internationally renowned university, also have one or more Max Planck Institutes or Helmholtz Institutes in the city. Particularly interesting are the industry relevant publications, which means publications with at least one author address of a company. In most cases, these are co-publications of universities or other research institutions like Max Planck with companies. They are on average about 8% of the total number of publications. And here we see the results. The total number of publications as a function of population size of a city. We see that there is no cumulative advantage for larger cities. The explained variance is also not very large. Then below, the number of industry relevant publications as a function of population size. Again, it's almost a linear relation with a slightly higher R squared, so explained variance. Then the relation between patent numbers and total number of publications. So in these slides, we looked at the number of publications as a function of publication size. And in these slides, we look at the number of patents as a function of the total number of publications and below as a function of the number of industry relevant publications. We see the relation is about linear. A further analysis reveals a moderate relation between patent activity measured by inventor addresses and industry relevant publications. Now, we conclude that science and technology are certainly heavily intertwined knowledge domains, but this does not necessarily reflect on the level of individual cities in terms of a strong relation between publication and patent activity.
Professor,
the relation between the number of publications in a city and its population size. And it doesn't scale super linear. It's about a linear relation. And then the next slide. Oh, yeah, okay. And then the next slide. Yeah. That's the relation between the number of patents in a city and the total number of publications above, or in relation to the number of industry relevant publications. And that's also a linear relation. Next slide. what we find is a slight relation between patent activity and the number of industry relevant publications. Yeah, next. Yeah, science and technology are without any doubt heavily intertwined knowledge domains, but it does not necessarily reflect on the level of individual cities, as we just saw, in terms of a strong relation between publication and patent activity. Yeah. Now, the conclusion is that individual city characteristics appear to be very decisive in the number of patents. When there is a large car factory in a city, it stands out in patent activity. For instance, Munich, Stuttgart. Having a large university is no guarantee for a city to have also a high inventive activity or high patent activity. So that's an interesting conclusion. And more of this research you can find in our recent publication in Scientometrics. And I also show you a Voss viewer, a map of the presentation. Just for fun. Well, thank you for your attention.